So today our goal is to simplify radicals. In order to do that, let's recall some information. So take a look up here. 5 squared. If you remember, that means 5 times 5, which is 25. 2/7 squared. Remember, you have to distribute that 2 to both 2 squared and 7 squared. So this becomes 2 times 2, which is 4, and 7 times 7, which is 49. In the third one, the negative is very important because it's inside the parentheses. So this is -3 times -3, which is a positive 9. And then in the next one, look what's in the parentheses being squared. So I have to write it twice. Now focus on the numbers first. 13 times 13 is 169. Then x to the third times x to the third. If you remember, when you multiply with the same base but a different exponent, or even the same exponent, you have to add them. So if I have 3 here and 3 there, I should have 6 total. And for the y's, if I have 6 here and 6 there, I have 12 total. And then let's talk about square root. Now you could do this right in the calculator, but let's think about it for a second. To find the square root of 36, I have to think about what number times itself will give me 36. If you said the number 6, then you are correct. So the square root of 36 is 6, because 6 times 6 is 36. Then coming over here, what number times itself will give you 100? And that answer is 10. I also have to focus on this right here. What variable times itself will give me x to the fourth? Now this is tricky because remember, when you multiply with the same base, what exponent do I need to have so that when I add it to itself, I get 4? So that would be 2 plus 2. So the square root of x to the fourth is x squared. Now see if you could do this next one. What number times itself will give you 81? What variable times itself will give you x to the 10th? And what variable times itself will give you y to the 8th? So the square root of 81 is 9. The square root of x to the 10th is x to the 5th, because 5 plus 5 is 10. And then the square root of y to the 8th is y to the 4th, because 4 plus 4 is 8. So that was just a little review. It's going to help us learn how to simplify these radicals. So in order to simplify these radicals, we need to know our perfect squares. So some of you, we already looked at some of them, like 36 and 100 and 81. But if you take a look at this first example right here, in this first example, 75 is not a perfect square. And if you're not sure, then you should take some time to list the perfect squares, at least the first 10, right on the side here. So I already did this previously, that's why it's already up here. 1 squared is 1, 2 squared is 4, 3 squared is 9. So pay attention to this side. These are all your perfect squares right here, or the first 10. So those are the numbers we want to keep a lookout for. So that's why I wrote them on the side. So take a look at this first example right here. I have the square root of 75. 75 is not one of those numbers, so it is not a perfect square. But I do need to find the largest perfect square that goes into 75. So to do that, I'm going to take my calculator, or you could do this in your head, and get all the factors of 75. So 1 times 75, 3 times 25, 5 times 15, and it looks like that's just about it. So those are the factors of 75. Now, how many of those are perfect squares? So if I look here, I have 1. I don't have 4, 9, 16, 25. So there are my perfect squares. Which one is larger? This one right here. So these are the two numbers that I'm going to use. So this is 25 times 3. Now, what is the square root of 25? If you look right here, what number times itself will give me 25? And that answer is 5. And then the square root of 3 is not a perfect square. So that is my final answer. I'm going to just make this a little bit smaller so I have more room for the rest of the problems. Okay? So that is how you simplify a radical. So I'm just going to keep working here. Let's look at this second number. If I look at this second one, it says here the square root of 16. Is 16 one of those numbers? It's right here. So this is already a perfect square. I do not need to break this down. What is the square root of 16? If I look over here, what number times itself? The answer here is 4. And that's it. If you want to pause the video here so that you could try these 4 before I show you how to do the answer, go ahead and pause it and come back in a minute or so. I'm going to continue now to solve these problems. If I look at this next one, 36. 36 is a perfect square, so I do not need to break it down. So the square root of 36 is 6, right? Then I look at 64. 64 is a number on this list, so it's a perfect square. So the square root of 64 is 8. But then now I'm looking at the number 80, and 80 is not on this list. You see, I get to 81, but not 80. So that means I need to break this down. So this number, I'm looking for the biggest perfect square that goes into 80. So let me take out my calculator. And if you forget how to do it in the calculator, you go into the y equals. You go 80 divided by x. And then you go into the table. So now that I'm in the table, I'm going to write down my factors of 80. I have 1 times 80, 2 times 40, 4 times 20, 5 times 16, 8 times 10, and that is all. So now if I look here, how many of them are perfect squares? I have 1, I have 4, I have 16, and those are all the perfect squares listed based off of that list. What is the largest, the biggest one? The number 16. So this is 16 times 5. The square root of 16 is 4, and I have a square root of 5. So there we go. That is simplified. And then the last one, I have the square root of 30. 30 is not here. It should be between 25 and 36, but it's not there. So I have to simplify it. So now I need to go get the factors of 30. So again, I get to my calculator, if you need it, to get the list of factors of 30. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So now if I look at the numbers here that are perfect squares, the only one I have is 1. I don't have any other factors to simplify it. So even if I wanted to do this, the square root of 1 times 30, the square root of 1 is just 1. 1 times the square root of 30, I can't do anything to it. So this is in simplest form. So you don't even need this work. If you know that there's no perfect square that goes into it, you can just leave it as the square root of 30. Okay, so let's take it a step further. I'm actually going to take my list of perfect squares and I'm going to bring it down because we need it down here now. So now let's learn how to simplify radicals with variables. So we just saw this in the do now. So let's take a look at the first example. In the first example, it has the square root of 36 and then it has y squared. So first of all, you have to ask yourself, is the 36 a perfect square? And the answer to that is yes. The square root of 36 is 6. So far, this is a perfect square. Now, taking a look at y squared, you want to ask yourself, what number times itself gives me y squared? And there is an answer to that. The answer is y. So this is a perfect square. So 6y is the correct final answer here. But now if I look at number 2, so I'm going to look right here. Look at number 2. Is 27 a perfect square? It's not. It should be between 25 and 36. So if I want to simplify this, I need to find the biggest perfect square that goes into 27. So I'm going to go into the calculator and do 27 divided by x in my y equals, and then go into my table and get those values. Okay, so there are my perfect squares. Here's 1, that's a perfect square, and here's 9. So the larger one is the 9. So square root of 9 times the square root of 3. And the square root of 9 is 3. Add 3. So far I've simplified the number, but I have not yet simplified the variables. So let's see how to simplify the variables. So let's look at the z. So I have the square root of z to the 5th power. How do I simplify that? Let's think. Now, if you want to do some work on the side, I'm going to show you something. Z to the 5th means z 5 times. So your question is, how many pairs, how many perfect squares do you have here? So I have z times z, that's 1. And here's another z times z, that's 2. And then I'm left with 1 left over. So if I look at this fully, I have 4 z's that are perfect squares, and I was left with 1 z. That's not a perfect square. So the square root of z to the 4th is z squared. And I'm left with the square root of z inside the radical. Okay, and then if you take a look at the last one, the square root of x, I can't simplify that any further because it's only one x. It is not a perfect square, so that is going to stay. So now my goal here, since these are the three parts to this problem, are to combine them. Notice, anything that's outside the radical will stay, I mean here there's just technically a 1, it'll stay outside the radical. So this final answer will be 3z squared. And then all of these inside the radical will be together. 3zx. So that is your final answer for this problem. I'm just going to try and make it a little bit smaller so that I have room for the rest of my problems. So if you want to pause it here and you want to try some of these and then come back and see if you did it correct, then you can do that. So I'm just going to continue showing the answers here. You could follow along with my work and see if you agree with my answers. I might change up some colors. So with a problem like this, when you have a number so big, sometimes it takes some time to find the perfect squares. Sometimes if you see it very early, you can just pick it. So 49 is a perfect square, so that's why I chose that one. So notice I kept the 7 by itself, and the 5q, since they're both inside a radical, I put them together. Oops. And the perfect squares here are 1 and 4. So the bigger one I'm going to choose is this one. Okay. Now remember, z to the 5th. That means z times z times z times z times z. So 5 z's. So here's 1 perfect square, here's 2 perfect squares. So in total, that's 4. And I'm left with 1 z alone. So the square root of z to the 4th is z squared. And I'm left with z inside the radical. And then the same thing happens with g to the 5th. I had to change color so it doesn't get confusing. So again, 1, 2, 3, 4, 5. So here's 1 pair and 2 pairs, so that's a total of 4 and 1 alone. So it worked the same way as the z. So now if I want to combine this into one final answer, always take the ones on the outside. And then in the inside, put all the ones inside together. So this one, this one, and this one. So there's your final answer there. So on the next one, I'm just going to start pulling out the answers. I'm getting all the factors for 567 right off of the calculator. I actually found already that the largest perfect square is 81 times 7. The square root of 81 is 9. So the final answer here is 9 rad 7. Or 9 times the square root of 7. So what you'll come to notice is that, especially with the variables, if it is an odd variable, so if the number is like 1, 3, 5, 7, you will notice those odd numbers are not perfect squares. Even numbers like 2, 4, 6, 8, those are perfect squares. So like for example here, the 8 breaks down to 2 rad 2. Now, y to the 7th, think about it. What's the largest even number? If I put all 7 y's, how many pairs will I get? I will get 6 pairs. I will get 3 pairs, which will be 6 y's, and I'll be left with 1 left over. So the square root of y to the 6th is y to the 3rd. And then I can't do anything with the square root of c. So my final answer, take all the outside ones. So this is an outside one, this is outside. And then take all the inside ones, inside the radical. So there it is simplified. Okay? So there's one last thing I want to show you if you want to take it a step further. This becomes a little bit more challenging. So take a look here. Look at what's different about these two problems. The difference is now I have a 4th root and a 3rd root. So I'm no longer thinking about perfect squares. I'm now thinking about perfect cubes and perfect numbers to the 4th power. So let's actually, in our calculator, get a few. So this is 1 to the 3rd, 2 to the 3rd, 3 to the 3rd. You don't need that many of them. So these are powers of 3, and I'll do the same thing with powers of 4. And you can do this just in your calculator. So 1, and then 2 to the 3rd is 8. 3 to the 3rd is 27. 4 to the 3rd is 64. 5 to the 3rd is 125. 6 to the 3rd is 216. And 7 to the 3rd is 343. So I actually should probably switch these because this problem right here is for the 3rd power. The top problem is for the 4th powers. So here 1 to the 4th power is 1, 2 to the 4th power is 16, 3 to the 4th power is 81, 4 to the 4th power is 256, 5 to the 4th power is 625, and 6 to the 4th power is 1296. Okay, so let's try these two problems and then we'll call it a day. So if I look at 567, I want to get the factors. So I go into the y equals. I'm trying to get the factors of 567. Okay. So I get 1 times 567, 3 times 189. You have 7 times 81, 9 times 63, and 21 times 27. So if I look at here at the list, how many of them are perfect powers of 4? So I have the 1. I don't have 16. I have 81. And that's it. So which one is bigger here? That's this one. Now look at the difference. It's the 4th root of 81 and the 4th root of 7. So I want to ask myself, what is the 4th root of 81? So look over here. The 4th root of 81, what number to the 4th power will give me 81? That answer is 3. Okay. Now when I look at the variable, this changes a little bit because I'm not looking anymore at perfect squares. I'm looking at perfect powers of 4 or groups of 4. So think about how many S's I have here. Oops. I have 9 S's. 1, 2, 3, 4, 5, 6, 7, 8, 9 S's. And I want to know how many groups of 4 I can make. So here's 1 group of 4. Here's 2 groups of 4. So in total, that's how many S's? So I can take out 8 S's, and I'll be left with 1 S. Right here on the outside, there's just 1. So how many groups did that make? 1, 2. So the 4th root of S to the 8 is S2 to the 2nd, because there's 2 groups. And then I'm left with the 4th root of S. Okay, so my final answer here, anything outside put together. So I'm left with 3S squared. And then these should be on the inside of my 4th root here. 7S. And there's your final answer. One more problem. A cube root, or the powers of 3. Again, focus on these different numbers now because these are powers of 3. It's always based on whatever number you see here. If you don't see a number, then it's perfect squares, which we did on the previous page. So what's cool about this question, if you take a look, 27 is a perfect cube. It's right here. So you actually don't have to break this one down. The cubed root of 27 is just 3. And then another thing here is if you look at the cubed root of g to the 3rd. Well, how many g's do we have? We have 3 g's. So how many groups of 3 can I make? I can make 1 group of 3. So actually the cubed root of g to the 3rd is just 1 g. So your final answer here is taking these two together and making your answer 3g. That was a little challenging. So this page is a lot harder than the previous page. So if you want some practice, there are some practice questions here. But there's also questions attached on the lesson here on Schoology, so you can actually practice your perfect squares. It's more important that you focus on these right here, because these are more important for you to know how to do. These here are just a little bit extra, a little bit more challenging. So do your best. If you have any questions, you know where to reach me. Good luck.